In this video, I'm going to demonstrate how to generate or create a footprint for any of the component in the Kicad. So, for example, to create a footprint, you should have a data sheet of the component first, and based on the data sheet, the physical dimension has to be checked in, and then accordingly we need to design the footprint for the component. In Kicad, most of the components are available and associated footprints are also available. So you can check it in the footprint library if you want to see what are the components. You can just use this the component window. Also, you can just go to here in the footprint in the Kicad. You can just go to the PCB footprint editor, go to the footprint editor and search the footprint requires the component, and if you want to create a new component symbol you can use symbol editor. So today I'm going to develop a component for one of the chipset called MLX9014. So this is actually a thermal sensor. So for that, first, as I said, you need to first find the MLX90614, the infrared temperature sensor. You need to download the datasheet, and this MLX sensor is from the Malik Semiconductor. So it is always better to search the component datasheet from the official websites. So here is the official website for the digital non-contact infrared thermometer. So that is MLX series. You can get some technical details in the data sheet. So what I'm going to do is I'm going to download the product data sheet. So once you download the product data sheet, so you need to open the data sheet, and in the data sheet you have to search for the dimensions of the component. So let's continue with the data sheet that we have actually downloaded. Okay, so it might be here in the download folders. Just go to the download folders, and yeah, here is the MLX datasheet that we are looking for. So open the datasheet of MLX. So this is the datasheet for the MLX 90614. So in this datasheet, you need to see the pin diagram first. So how the component pin marking is done. So based on that, so here is the component pin marking. So this is the component. So 1, 2, 3, 4. It's a 4-legged device. It's a through-hole component, and each of the component, the pins are also identified. So this is the one thing that is supposed to look into the functional diagram. Then go to the last page. You will get the package information. So usually that will be provided in the last page of the data sheet. You can just see here in the always in the content page you can find part marking. Okay, so the part marking, you get the package information. So that is here. So go to the page number. Yeah, so this is actually the part marking page number, package information, that is here. It is MLX 90614 that we are referring. So here is a part. So this is a diagram that you're supposed to consider. So according to this, and you can see here, it is having a radius. Okay, so the notch is put at 45 degree from the pin number 1 2 from the origin, and you can see here 45 degree there is a notch, and this particular the radius of this is 0.45 mm, and it's the dimensions also given here. You can just check it out here, and the width of the component and other details also mentioned. So we need to design the, okay, so let's look at this here. So this particular hole is 0.45 and the pad is 1.60, and you see that arc, okay, this arc is 5.08 mm, okay. So the 5.08 mm from this center to this center. So we need to define in a similar way. So let's continue creating the component for this. So in the Kicad, we need to create the component. So you can just search first whether the required footprint and the component is available or not. So it will load the libraries. So usually most of the component footprint is available, but we can just cross check once. MLX90 6, it's not there, so we don't have that component footprint available, also the component. So what we do is we go for the symbol editor. So in the Kicad you have create delete symbols. Click here, it will actually take you to the symbol editor, and now you can create a new symbol here. You need to mention from which section or the library you want to create this component. So actually this is a sensor for the temperature. Under this we create MLX90614. Okay, so say okay. We need to create a component for this, so I'm going to use this M. Okay, so we just take this away, can take this away, that. Okay, so let's create a component for this. Okay, so you can make this U and MLX separate. Okay, at least over here. So now you need to create the symbol for the component. So what you can do is, as in the data sheet what you have seen, it's a circular symbol, and you can see this pin number 1 in the data sheet. It's given very clearly here, pin number 1, 2, 3, 4 in the anti-clockwise direction. So we will use a similar method here. So to so you need to refer to the function diagram, and better to represent the same notations that is given in the schematic. So I will shift over between this. So what I'm going to do, I'm going to create a circle. Yes, I think this is almost around 2.54 mm. Okay, now I need to create a pin for this, and as you can see here, notch is given here, so that is not necessary for time being. So what we'll do is we'll create a pin here, and this pin reference is SCL, pin name is SCL, and the pin number is 1, and this is an input pin, and direction you can just say it is top, it is down. Okay, so that you can zoom out and you can place it. Okay, so this is actually an input pin, and pin name is SCL. So if it is too, what I can do is I can just increase this dimension diameter again. Okay, so this is the one, and then put up okay, so connection type as input. Graphic, I think we can have, so this is SAL, pin number is 1, and okay, what is expected is the grid view. Grid has to be here. So you choose a grid view that is required for you, that is SCL, and one more is SDA. Number here, we'll place it here, SDA, and this is pin number 2. Again it is input, and I will give it as right side. This is pin number 2. Okay. Fine. This is pin number 2, SDA, SCL. There is one more pin that I need to give it here. So let me move this further. So here, select this, move it over here. I'm going to create one more pin here, and the pin name that I need to give is VDD, and pin number is 3, and this is actually the power. This is actually the power input. This line you can leave it as it is, and it is up. So I think this looks good. Okay, you can move this a little bit away this way. And one more pin that is required is here. I'm going to add it here as VSS, I guess it is VSS, that is ground, VSS, and pin number is 4. It's again the power input, or you can just can give it as unspecified also, and this can be left. So, okay, so I can create it in this way now. So this component is ready. So 1 2 3 4, and you save it. So this component is saved under MLX90 614. So now let's create another component is ready. You can actually close this, and you can actually go to the Kicad schema. Under Kicad schema, now I can actually search this component here. Just see here, I'm going to add the component MLX90614 is here under temperature sensor. So I have this component here. So this is my component. So I need to create a footprint for this component. So obviously footprint of this component is not available. So to add the footprint, again you need to look into the data sheet. Go to the last page as I mentioned, where you get the package information. So and look at the package information carefully and do the design accordingly. So here is the package information for MLX90. There are different families, I think almost You have to choose which family. We will be referring to the first one. Okay, MLX 9064XXA we will look into, and we will design that. So these components, if you see the dimension of this, okay, if you look at the dimension, that's how it is placed. So if you look into this diagram, it indicates that its radius of this particular inner circle is 5.08 mm, and the pad, the whole diameter is 0.45 mm, and the pad diameter, the copper pad, is 1.60 mm. So anyway, this is of not so important for us, but we can consider it. But what is important is this. So the way in which it is placed. So we will create first an outer line which indicates the component area. Okay, how much exactly the component area that covers. You can look at the side view or the top view of the component here. Top view of the component represents the component takes the diameter that is 9.2 mm. It's actually 9.2 mm is the diameter, and the inner diameter of the component where exactly the sensor window is kept, that is actually 5.6 mm. So we will have these two of these circular rings in the footprint as the uh, a top silk layer. Okay, so I'm going to do that here. So what we do here is we need to go to the first to the Kicad, and we will see here footprint editor. So just open this footprint libraries. So I'm going to strictly follow these dimensions for plotting the footprint, and the diameter of the component is 9.2 mm, and the inner sensor is 5.6 mm, and there is one more inner circle is there which is 3.5, and we can also get the bottom view where exactly the through hole, the leaves are supposed to be placed with the in the circumference of circle, where the diameter of the circle is 5.808 mm. The pad dimension is also given. So now let's try to plot this on the Kicad. So in the footprint editor, you need to create a new footprint with the name PO-39, and we create a footprint with that name so that it can be used as a standard throughout the. So let's create that. Move this, so make use of the shortcut key as much as possible. Okay, so now let's get into the center origin and make sure that your grid setting is somewhere. What is the grid that we have? Almost, yeah, 0.1 mils. That's nice. So what we do is we are going to create now a marking on the fabrication layer, that is front fab layer. We will have a mark, that is this one marking will do outer circle. Then all top silk marking will do that appears on the PCB front top layer. So there are two layers you needed to make. One is for the fab layer, another is for the top silk layer, and another is actually the copper padding we need to do for the component. So those three things that is. So one we will put it to F fab layer, another will put it to the top silk here, that is actually the forward silk, front silk, and another is actually bottom copper. So this is what is required. So we'll start with the front fab layer, and we will use a circle here, add a graphic, you set the origin here and simply draw a line, draw a circle, edit the circle. What the center of the circle I want it exactly at 0, and the radius I want it to be, look at this, it is 9.12, so half of it is 4.6, so we will give the radius as 4.6 mm. So thickness you can keep it as it is. So this is my the fab circle. Okay, so now what I'm going to do is I'm going to make another circle for which with that having this 5.6 mm. Okay, this 5.6 mm circle also will do. Use this one, make a markings and edit it. Now change it to 0, y also 0, and radius is half of that, which comes around 5.6 is half of it is actually 2.8. 2.8, so we can keep it as 2.8 mm. So this is my inner circle. Okay, this fab, I think this is enough for your fab layer. Now whatever we do, we will do it for the marking and all, we will do it on the top silk. Okay, now change the layer to the front silk layer. Okay, front silk layer. Now you need to again do a marking, add graphics line, so just center, approximately put it at the center here. We need to make another circle, just edit it. Now this I want it to be 0, y also 0, and my radius I want it exactly as that 9.12 mm is actually the diameter, half of it is actually radius, which is 4.6. Now 4.6 will exactly comes over that, so what I suggest is you can keep it around 4.8, okay, which will be something little more than that. Okay, so 4.8 m. So this is what I'm going to keep. So another outer, another ring. Now this will appear on the front layer, I mean the top silk layer of the PCB as a printed thing. Okay, this particular line. Now I need to make a marking here. That marking, you see the marking is exactly at 45 degree. Okay, from the top view, if you see, if I'm going to place this, so marking is exactly at 45 degree angle. The angle is given over here in this bottom view, they have mentioned it is 45 degree. So we need to create a marking of 45 degrees. This is the indication of a notch, so we can assume some dimension for that notch. So what we can do is we can take this arc here, roughly you can take an arc and you simply point it towards the center. Okay, so where you can start, we can actually zoom in if you want still more clarity. Okay, exactly at the center. Now you see here, you want it exactly at 45 degree. Okay, so 45 degree will come somewhere here. This is 45 degree. So now I need to make a notch here at 45 degree. So I'll consider 2 mm towards the from the right side and 2 mm again extended towards the left side. So I think you can take it and marking for that notch, it will take around 4 mm width. So that I will start from 43 degree. So we'll start from 42 degree. Okay, we'll start from 42 degree. So that 42 we will start, and thickness for that you can assume maybe, I think this much is enough, because this is just an indication for the user where the knot is. So we will start from 42 degree. Sorry, 42 degree I will start somewhere here. I will start. Okay, so this is 42 exactly. So roughly I will start at 42. So I will start 42. This is now 45. So 3 plus 48. So this is now somewhere here I will start. So this is the notch. So this is the notch, and I'm going to make this adding the graphics line. From this point I'm going to make a marking. I'll pick it over here, and approximately you can take it, or you can just escape, make a new marking over here. Yes. So we did a marking of this way for the notch. So I think this is more enough for us to make this marking for the and if you want to make a further let's go with the bottom actually, where we need to place the pad, and we have to be careful when you are actually deciding the pin numbers for this. So we will start exactly by putting the marking here. So we are exactly at the origin, so it is easy for us to give a exact position for this. So it is at the x-axis, so this is 5.08, that is actually diameter. So 2.04 is sorry 2. So 2.54 mm, 2.54 mm is going to be the radius. Okay, so we can actually easily place a pad here. Just take this pad, add a pad. So we will change the attribute of the pad later. So let me press it somewhere here, and one pad I'll place it roughly over here. Sorry, this is actually on a different layer actually. So we need to change the layer to the bottom copper, and I'm going to place it somewhere here. I'll place it. Sorry. Okay, we do this. Okay. Okay. So we will place the pad. I'm going to edit this pad. So numbering I will check it later, not now. So let me worry about the dimension of this. So x-axis dimension supposed to be 2.0, 2.54 mm. Okay, and y-axis is exactly 0. And size of the pad, if you see, it's given as 1.6. Okay, so we can make it as 1.6 mm. And the hole size is also mentioned here. The hole size is 0.45. You can make it as 0.45. So that's going to be the hole size. So I think that's more enough for this. So now your pad section is fixed. So similarly you do it for the next one, and another one over here. Now we need to exactly the orientation for this. So what I'm going to do is I'm going to select each one of this pad. I'm going to edit it. Now here x is 0 and y, if you see, it is minus 2.54 mm. This is 1.6 and 0.45 exactly. And if you look at this, this is going to be again minus 2.54. Y is going to be 0, rest all going to be the same. And this one again, this is going to be 0, this is 2.54, and rest all going to be the same. Okay, now what we need to do is we need to worry about the pin numbering. Okay, whatever the numbering is given is wrong, because if you look at the schematic here, we have started with the number 1 2 3 4. So our numbering in the Kicad library, the footprint also exactly 1 2 3 4. So let's see which is supposed to be 1, which supposed to be 2 3 here, which supposed to exactly match to the actual device. Okay, now this is nowhere having a physical dimension, it is just a pin name. So pin 1 number is SCL is 1, pin number 2 is SDL. So we need to see how to map this actually. For that you have to look into the data sheet first. So they have given the bottom view. They just give a bottom view. They never mention any pin number here, but they mentioned only the fourth pin. Look at the image here. Okay? Look at the pin diagram. They given it in the beginning. Look at this. There is something called as pin definition. Pin numbering is given so that here, here they give the pin definition. Okay, here they gave a pin definition, and then they said that this is going to be the bottom view. So if this is going to be the bottom view, if you tilt this to 45 degree, okay, if you tilt this particular notch to the 45 degree, then this particular thing will come on the x-axis, that is 1, and 2, 3, 4. It goes in a clockwise direction. So pin number 1 will come on the x-axis, then 2, then 3, then 4 will come if you tilt it. That's going to the bottom view. But what we have here is a top view. Look at this. This is pretty confusing, but you can actually make it. This is very important to make. What we have is actually the top view. Okay, so here what I'm going to give is pin number 1, 2, 3, 4. Okay, I'm going to tilt it. So what we do here is we have to look into the data sheet. Data sheet is bottom view is given, but what we have is actually the top view. So it will exactly becomes the mirror. Okay, it will exactly becomes the mirror. So whatever we have to do here, so this becomes exactly mirror. Now this is the bottom view, so you need to change the orientation in the clockwise direction in the PDF in this here, and this becomes the pin number 1. Edit it, mark it as pin number 1, say OK, and see here, this is going to be in the bottom view, actually the clockwise. Okay, it's going to be in the clockwise, but here it becomes anti-clockwise. We need to save it as pin number 2. This will be pin number 3, and this is going to be pin number 4. So yeah, this is what we did it. PO39. We need to save it. Save. Okay. Okay. So we will save it to a specified library. We will save it under sensor. Sensors. Okay. So this is saved now. So what we do with this? So we need to now go back to the Kicad schematic and edit this, and footprint should selected, and under this you search the footprint under sensor, because we saved it under sensor. Sensor is here. Under sensor we save it as PO39, and this is the one that we supposed to assign. So double click here, say OK. So your footprint is assigned. Now you can go to the PCB layout and do the tracking. So this is how the footprint is created, by looking at the physical dimension according to the data sheet. Okay, thank you.